Hello guys, these are the problems that you might have issue with section 4.1. So we can go through. Let me tell you how to actually solve for these type of stuff. So the very first one is when you have the graph, the very first thing is put them in shape. So this is the original one. So in order to do that, so we just put them in shape. So what I do is I 1, 2, 3, 4, 5, 6, 7, 8. So you basically put in the shape that is the easiest. I'll say something like triangle, rectangle, or square will be the 3 common easiest ones. So you can use the shape for calculating your numbers. So the first one I do for number one, shape 1. I have 2, shape 2, 2, 3, 4, 5. This is what I have for each shape. So now we're just going to look at 0, so 0 and 4, from 0 to 4. So we have shape 4, 6, 7, 8. So 4, it's 1, 6 is 2, 7 is 1, and 8 is 2. So we ended up with a 6. So negative 2 to 2, we have 3, 4, 5, 6, 3, 4, 5, 6. 3 is 1, 4 is 1, and then 5, 6 is 2. So you have 1, 1, 1 plus 1 plus 2 plus 2 equals to 6. And then from negative 2 to 0, so you only have 3 and 5. So 3 is 1, 5 is 2. So you ended up with 3. So negative 4 to 4, which is everything, you can directly add all the number up. So 2 plus 2 plus 1 plus 1 plus 2 plus 2 plus 1 plus 2. And you ended up with 13. So this is the answer for section 4.1 problem 2. Now moving on to question 6. So you basically give you a function. It's presented by the graph in the textbook. So to estimate the area under the graph on the interval from negative 4 to 4, we use left rectangle approximation with 4 rectangulars and obtain that the area is approximate. So for this one, it will give you approximate using the left rectangle. So the very first step you will need to do is draw out the rectangle. So your first step, have to look for what is the interval, which is 8. So you have from near 4 to 4 is 8. And then you have to divide it by 4 because it's given as tell you use the left rectangular approximation with 4 rectangulars. So once you have that, you're going to point it out all the points. So first one we have. So the first thing is like draw the red ones that I have shown here. So the first one's negative 4, and you skip 2. You're at negative 2. You skip 2 at 0, and you skip 2 at 2 and 4. And then you're going to do the height. So this one, since it's asking a left rectangle, so you're basically going to go for the left one. The point is on the left. So 3.5, 2, 0.5, and 2.5. So you just calculate the rectangle. So 3.5 times 2 is 7, 2 times 2 is 4, 0.5 times 2 is 1, 2.5 times 2 is 5. So once you add everything up, you will have 17. So if it happens to be the right rectangle, so you basically, the number you're going to use is 2, 0.5, 2.5, and 1. So that's number 6. Going down to the next one. So this one, it's going to be, the graph is showing the velocity function, v is equal to v of t. Velocity is given below. Determine the distance traveled during the following time interval. So you have to do 0.08, 0.26, 2.24, 4.28. So the very first step is just what I said, put up the shape. So something like this, it's kind of a little bit, sometimes you might calculate it wrong, but it's easier if you actually just put them in as a triangle and a square. So I only have 4 shape, which is 1, 2, 3, 4. And then for a triangle, I use 1/2 base times height. For square, just side times side. And then that's for this one. So now you're going to look at there for 0 to 8. So you have 0 to 8, which is 1, 2, 3, 4. So you add everything up. 3 times 40 plus 200 plus 50. You ended up with 320. and 0 to 6, you have 1, 2, 3. So you add 30 plus 40 plus 200, which is 270. So 2 to 4. So 4 is in the middle. So you basically, 2 to 4, it's going to be half of the 2 to 4. Or actually 2 to 4, it's going to be half of our shape for 2 to 6. That's 2 to 6, so we ended up with 200. So in order to get half of them, you basically just 1/2 of number shape 3. So you ended up 100, and 4 to 8. So 4 to 6, so which is 1/2 of the number shape 3, and you have 4. So you're basically going to do 1/2 200 plus 50, since 4 is 50, and you ended up with 150. Moving on to 26, so if a closed manufacturer has the marginal cost function, marginal cost of x equals to 15 minus 0.06x, and the x is going to be between 0 to 100. So whereas the x is the number of suits produced each week, the fixed cost is 200. So we all know the total cost is going to be the integral of marginal cost. So your first thing is doing the integral of 15 minus 0.06x, which is you ended up with 15x minus 0.03x squared. And for the fixed cost, since you were looking for total cost, you have to include the fixed cost, so which is you're going to add instead. So you ended up with 15x minus 0.03x squared plus 200. And your C of 80, you just plug in the 80 because for this problem, it asks for the total cost of producing 80 suits. So once you have this one, and you plug in the 80, you'll end up with $1,208. And then for next one, a clothes manufacturer has a marginal revenue function. So this one's really similar to the previous one, but this one's the only difference is this is revenue, the previous one's cost. So the total revenue function is going to be the integral of marginal revenue. So you're going to do the integral for 30 minus 0.2x. So after that, you will have 30x minus 0.1x squared. So there isn't anything other than the equation is given, so you just directly plug in 60 based on the question is already given. So 60, and then you will end up with 1,440.